Did you realize that 92% of automatic transmission failures stem from a component smaller than a golf ball? Stay with me until the very end because I will unveil industry secrets that even certified technicians often overlook in their daily practice. Welcome to Advanced Automotive, your premier destination for professional vehicle maintenance expertise and insider knowledge. The transmission solenoid valve serves as the hydraulic command center of your automatic gearbox system. This remarkable engineering marvel controls fluid pressure with surgical precision, responding to electronic commands within microseconds of activation. Unlike traditional mechanical valves, it operates through electromagnetic pulses that create variable flow patterns throughout the transmission network. The powertrain control module communicates with this solenoid through sophisticated binary codes, orchestrating seamless gear transitions under all driving conditions. Whether you drive a conventional automatic, dual-clutch system, or continuously variable transmission, this component remains absolutely essential for proper operation. Typically housed within the valve body assembly or integrated into the hydraulic control unit, it bridges advanced electronics with precision hydraulics. Before we dive deeper into these professional insights, please subscribe to our channel and hit the notification bell. Your support drives us to create increasingly specialized content that helps you maintain peak vehicle performance year-round. First warning indicator: harsh engagement during gear transitions that feel like mechanical jolts. When your vehicle lurches forward like a bucking bronco during shift points, the solenoid valve may be malfunctioning critically. These violent jerks indicate improper hydraulic pressure modulation at the most crucial moments of gear engagement. The transmission fluid fails to flow with proper timing or reach adequate pressure levels, creating devastating mechanical shock waves. These uncontrolled forces prematurely destroy clutch packs, brake bands, and other internal friction components throughout the transmission assembly. Second diagnostic clue: the intermittent illumination of your transmission warning light on the dashboard display. This indicator serves as your most reliable early detection system for developing transmission problems. The engine control unit monitors hydraulic irregularities continuously and triggers this visual alert immediately upon detecting anomalies. A deteriorating solenoid produces erratic pressure variations that sophisticated sensors recognize instantly as abnormal operating conditions. This warning should never be dismissed because it typically precedes catastrophic failures requiring thousands of dollars in repairs. Third troubling symptom: the sensation of gears slipping unexpectedly while under acceleration or load. Picture pressing the accelerator pedal and feeling your engine rev wildly without corresponding increases in vehicle speed. This frustrating experience indicates internal friction element failure caused by insufficient hydraulic clamping pressure. The solenoid valve cannot maintain adequate pressure to ensure firm coupling between all rotating transmission components. This phenomenon usually accompanies excessive engine RPM without meaningful power delivery to the wheels. Fourth audible warning: unusual metallic sounds emanating from the transmission during gear changes. Grinding noises, metallic clanking, or high-pitched whining sounds serve as unmistakable indicators of serious internal problems. These disturbing sounds result from forced gear engagement without proper lubrication at critical friction surfaces. The failing solenoid disrupts smooth fluid circulation, creating areas of excessive friction and heat generation. These destructive forces produce microscopic metal particles that contaminate the entire hydraulic system progressively. Fifth operational issue: significant delays between gear selector movement and actual gear engagement. You shift the transmission and several seconds pass before the vehicle responds to your input command. This lag reflects abnormal slowness in pressurizing the appropriate hydraulic circuits for gear activation. The solenoid valve struggles to open its calibrated orifices fully, dramatically slowing the engagement process. This delay can become dangerous in traffic situations requiring immediate vehicle response for safety. Sixth mechanical problem: complete inability to shift out of a single gear regardless of driving conditions. Your vehicle stubbornly refuses to leave first or second gear, despite repeated attempts at manual shifting. The solenoid remains frozen in an intermediate position, preventing any variation in internal hydraulic pressures. This condition forces the engine to operate outside its optimal efficiency range, causing overheating and accelerated wear. Mechanical components then experience excessive stress that can cause completely irreversible and expensive damage. Seventh automated response: activation of transmission limp home mode that severely limits vehicle performance. Your vehicle's computer automatically restricts power output to protect the transmission from further internal damage. This intelligent safety feature limits available torque and locks the transmission into a single survival gear. The system detects solenoid failure and immediately implements this emergency protection protocol. While inconvenient, this limitation allows you to reach a repair facility without causing additional mechanical destruction. Eighth economic consequence: dramatic increase in fuel consumption during your regular driving routines. Your vehicle suddenly demands 20 to 30% more fuel than normal operating conditions require. Improperly synchronized gears force the engine to compensate through constant excessive RPM operation. This energy inefficiency results directly from inadequate hydraulic pressures generated by the malfunctioning solenoid valve. Your household budget immediately feels these consequences during every visit to the fuel station. Ninth olfactory evidence: the distinctive smell of burning transmission fluid or overheated mechanical components. An acrid, persistent odor escapes from under the hood, particularly noticeable after demanding driving conditions. This smell definitively signals transmission fluid overheating caused by uncontrolled friction between internal components. The defective solenoid creates chaotic pressure conditions that cause critical overheating of all internal mechanisms. This thermal degradation permanently alters the lubricating properties of transmission fluid, exponentially accelerating general deterioration. 10th and final symptom: completely unpredictable transmission behavior that defies logical explanation. Your transmission seems to have developed artificial intelligence, shifting gears according to mysterious internal criteria. These random variations result from distorted electrical signals generated by the dying solenoid valve. The computer receives contradictory information and adapts its commands in completely incoherent and dangerous ways. This instability makes driving hazardous and requires immediate professional mechanical intervention. To enhance your technical understanding, let us examine the fundamental causes of these specific solenoid valve failures. Natural wear represents the primary factor after 175,000 miles of intensive daily operation. Electrical windings deteriorate gradually under repeated thermal cycling within the engine compartment environment. Transmission fluid contamination equally represents a relentless enemy for these precision-engineered components. Microscopic metallic particles generated by normal wear progressively clog the most delicate internal mechanisms. Transmission fluid quality plays a decisive role in solenoid valve longevity and reliable long-term performance. Degraded fluid loses its anti-foaming and detergent properties, encouraging formation of sticky deposits throughout the system. These residues gradually obstruct precisely calibrated orifices, disrupting exact pressure modulation capabilities. Respecting manufacturer-recommended service intervals proves crucial for preserving these expensive components. Unfortunately, many vehicle owners neglect this preventive maintenance despite its relatively modest cost. Operating environment significantly influences transmission solenoid valve durability under real-world conditions. Urban driving conditions with frequent stops stress these components more than steady highway cruising. Sudden load variations during acceleration and deceleration create destabilizing pressure spikes throughout the system. Performance driving with high RPM operation generates additional thermal stress particularly harmful to these mechanisms. Repeated towing or heavy load transport dramatically accelerates the premature wear process. Regarding professional diagnostic procedures, several methods enable precise identification of defective solenoid valves. Diagnostic trouble code reading constitutes the essential first step of any serious technical investigation. Modern diagnostic equipment reveals real-time operating parameters with extraordinary precision and reliability. Electrical resistance measurement of solenoid windings detects short circuits or internal breaks invisible to visual inspection. Hydraulic pressure testing confirms effective modulation capability of each installed solenoid valve. Automotive oscilloscopes enable detailed analysis of command signals sent by the powertrain control module. This approach reveals electronic malfunctions frequently invisible during conventional static testing procedures. Dynamic pressure curves highlight abnormally long or excessively short response times under operating conditions. This diagnostic precision prevents unnecessary replacement of components still functioning but incorrectly suspected. Repair costs vary considerably depending on accessibility and complexity of the affected solenoid valves. Some vehicle designs require complete transmission removal to access the valve body assembly. This intervention can represent 12 to 18 hours of specialized labor depending on vehicle architecture. Other designs allow direct access through simple removal of the lower transmission pan only. New solenoid valve prices range from $120 to $500 depending on technological sophistication. Original equipment manufacturer parts guarantee perfect compatibility, but represent the most expensive option available. Quality aftermarket equivalents offer an attractive compromise between performance reliability and economic considerations. Beware, however, of cheap counterfeit parts that can irreparably damage your extremely expensive transmission system. Warranty coverage serves as a reliable indicator of supplier confidence in their marketed products. Several simple preventive measures significantly extend transmission solenoid valve service life. Strict adherence to recommended service intervals forms the fundamental basis of effective preventive maintenance. Exclusive use of manufacturer-specified fluid prevents potentially destructive chemical incompatibilities. Regular visual inspection of fluid level and condition enables early detection of concerning degradation signs. Smooth driving without abrupt jolts preserves these components sensitive to sudden pressure variations. Avoiding repeated overloading preserves the entire transmission system from unnecessary excessive stress. Engine warm-up in cold weather ensures optimal fluid viscosity before initial mechanical demands. This simple precaution prevents circulation of excessively thick fluid capable of damaging delicate internal mechanisms. Level parking facilitates natural fluid circulation and prevents harmful partial system bleeding. When symptoms first appear, rapid intervention can sometimes prevent complete solenoid valve replacement. Professional hydraulic system cleaning eliminates contaminants before they cause completely irreversible damage. This preventive procedure typically costs 10 times less than replacing a completely failed solenoid valve. Specialized additives can temporarily regenerate seals hardened by natural aging processes. If you recognize several of these symptoms in your vehicle, do not wait for the situation to worsen dramatically. Early diagnosis will save you extremely expensive repairs and significantly extend your transmission service life. Please subscribe to our channel and activate notifications to never miss any of our expert insights. Your support tremendously motivates us to continue this mission of accessible automotive information for everyone.